everyone. Today our group is going to present the applications of discrete structure in election voting system. We chose the 50th National General Election of Malaysia, which is GE15, for our case study. Elections are very important for democracy. However, big elections have big risks like people were voting mistake or counting in mistake. Our objective is to use math concept like election and counting.
We looked at the data from GE15. In this election, approximately 900 candidates competed for 222 parliamentary seats. This is a massive amount of data. We found two main problems. The first is a verification problem. We must enforce the one person, one vote principle. The challenge is to stop fraud and make sure every vote is valid. Second is aggregation problem. This is about counting. How can the system count countless votes efficiently? As we will show, manual counting causes errors when there are many choices.
So for the first concept, we have relation. And then for relation, the set definitions, we have two main things, which is a domain and co-domain. For domain, it will be our registered voters, and our co-domain will be our candidates. The mechanisms of it, for relation, or the rule, every element of V in set V links to exactly one element of C in set C. This mathematical property prevents double voting. If a voter maps to more than one candidate, it violates the definition of a function triggering an error. So now moving on, we have three types: reflexivity, symmetry, and transitivity. So for reflexivity, we will have this thing, meaning that A pairs are in set R, meaning that A is related to its own self. Often used in formal verification to ensure all elements of the set possesses a foundational property. For symmetry, if A and B pairs in set R, then B and A pairs in set R as well. Defines relationships where the order of declaration does not change the mutual link. For transitivity, if A and B pairs in set R and B and C pair in set R as well, then A and C will be also in set R. It is a must for any preferential voting system to work logically.
So for concept 2, we'll be doing combination and permutation. But first I'll talk about combinations. And here's the formula. So given a scenario where a single voter votes for 8 candidates with only 3 available seats, where n equals 5 and r equals 3, the calculation will be 8 combination of 3, which gives 56. So this shows that there are 56 possible winning groups. And the key is order does not matter. It helps the election planners to understand how many outcomes are possible. It also shows whether the rule scales well as candidates increase to ensure the practicality and accuracy of results. Next, I'll talk about permutation. So here's the formula. And again, same thing. Given a scenario where a single voter votes for 6 candidates and only rank the top 3 candidates, where n equals 6 and r equals 3, the calculation will be 6p3, which gives 120. So this shows that there are 120 unique ways for a single voter to fill out a ballot, and the key is order always matters. As for the implication, it shows that the manual counting of 120 variations for millions of voters is impossible and error-prone. And the solution is that a computerized relation matrix is required to organize and store these complex preferences data efficiently.
When we tested our model with real GE15 data, we found a limitation. Our first model assumed a total function. This means we assumed every registered voter would vote. But in reality, the voter turnout was approximately 73%. This means 27% of people did not vote. So our improvement is to use partial function. This allows the system to accept that some inputs are identified, means the person abstained without calling it a system error.
So in conclusion, discrete structures are essential for election integrity. Like for relations, it successfully enforces the uniqueness constraint for security, and permutations highlight the complexity that necessitates computerized matrices. So for recommendation, is future systems should implement bijective function, which is 1-to-1 and onto, and this can ensure strict voter anonymities and guarantees no voters are missed in the tally. And the next recommendation is digital election matrices is essential for handling large data sets such as 900 plus candidates effectively.